Very good morning and welcome to the video lecture 3 on Introduction to FEM, first module. So, in the last class, we have discussed about the introduction to FEM, the history of FEM, advantages and limitations, and some applications. And in this lecture, we shall discuss about the types of force used in the FEM and how the discretization process takes place in FEM. Okay, so usually the forces are classified into two categories. One is the internal force and another is the external force. And as you all know that internal forces are the forces which are set up due to the external forces. They are simply known as the reaction forces, okay, or the resistance force you can say, right? And the external forces are those forces which are acting external to the body, okay. Simply the name itself indicates external force is the one which is acting external to the body. So we will discuss the types of the external forces one by one. So here is the first one, the body force. Here, when the force is uniformly distributed throughout the volume of a body, then it is called the body force. Here body force is nothing but each and every part of the body experiences a force. That kind of a force is called as the body force. So here we have an example. Forces due to gravity, electric fields and magnetic fields are the some examples of the body force. And even you can say the weight of the body, which is also a body force, because each and every part of our body experiences that force. Okay, such a force is known as body force. Next, we will have a surface force, or it is also called as attraction force. Here, when the applied force is uniformly distributed over the surface of the body, then it is called surface or traction force. And here the examples are friction force and traction force. As you know that friction force is the one which is acting over the surface of the body, two bodies you have discussed. So this is considered as the surface force because when the applied force is uniformly distributed over the surface of the body. Okay, and one more example you can take is the uniformly distributed load, UDL. Okay, in the strength of the materials you have studied SFT and DMD, where the load is uniformly distributed throughout the entire span of the beam. So such a force we can consider it as a surface force or traction force. And the last category is a point load or point force. Where the force is applied at a particular point of the body, then it is called a point force. It is very simple. Okay. Then we will discuss the types of the FEM. So yesterday we have also discussed regarding the steps involved in the FEM, where you have the discretization process, which is a very important step, and this is the first step in the FEM. So discretization also involves whether the discretization is to be performed by taking 1D element, a 2-dimensional element, or a 3-dimensional element. So these types of the element play a very vital role in deciding the solution of the given problem. So here we have a classification like 1D element, 2D element and 3D element. Here 1D element is nothing but if the displacement at each node of the element is expressed in only one direction, then that element is called as 1D element. So a discretization process involves dividing the given continuum or the given body into smaller number of parts called elements, and each element is connected with the special joints called as the nodes. So element and node is very important in finite element method. Okay, so here 1D element is nothing but If the displacement is expressed in only one direction, it is called 1D element. Okay. Whether in the positive x direction or negative x direction, it is considered as a single displacement. It is called as 1D element. Here the example are line element and bar element. We will discuss what is this bar element and line element in the next coming problems. Okay. Next one is 2D element. So again the name itself indicates here the displacement at each node of the element is expressed in two mutually perpendicular directions. Then such a element is called as 2D element. Here the examples are a triangular element and quadrilateral element. Again there are so many kinds are there. A CST, LST. Okay, most commonly used 2D element is a CST, constant strain triangular, or you can say LST, linear strain triangular. We'll discuss that. Here each node consists of two directions, that is x direction as well as y direction displacement. If the same node has two displacements, it is 2D element. If a node has only one kind of a displacement, it is 1D element. Next, coming to the 3D element, here the displacement at each node of the element is expressed in three mutually perpendicular directions. Okay, here each node has three kinds of a degree of freedom, or three kinds of a displacement in a different direction. So such an element is known as 3D element. Here prism, tetrahedron, hexahedron are the best examples for a 3D element. Next we'll see examples. Here they have shown how the element shape and element names are given. So here 1D element is nothing but a line element. So here spring, damper, beam, truss, you will get as a 1D element. So here first order element and second order elements are given. First order consists of a simple one element with two end nodes. If you consider one more middle node, then that becomes a second order elements. And even you can proceed with the third order also by taking the two more nodes at the center. So totally 4 nodes you will get. That is third order element you can say. Then 2D element. Here shell, plane 2D elements are there, and here most commonly used 2D element is, as I said, it is a CST, that is constant strain triangular element. So triangle consists of 3 nodes. It is nothing but a simple 2D element, and this is a complex 2D element which consists of again the center nodes as well. In addition to the end nodes, you have a center nodes. This is called, these two are 2D elements, and even this is a rectangular element or a square element, that is also given as a 2D element. And 3D elements, hexahedral and tetrahedral. So this is a simple hexahedral, this is a complex hexahedral. This is a simple tetrahedral, this is a complex tetrahedral. Complex indicates second order, third order derivatives of the elements. Okay. Next, steps used in FEM, this we have discussed in the previous class. First one is discretization, that is dividing the whole quantity into smaller number of parts called elements. Then we need to find the local stiffness matrices, that is depends on the number of elements you are dividing. Those many stiffness matrix you will get. Then those many stiffness matrix you need to assemble to get the global stiffness matrix. Then by applying the boundary condition, you can find the finite number of unknowns, and then the result is to be plotted.